On Tuesday, October 10th, an experimental Vans RV-8 crashed in Centerville, Utah, killing its pilot Donald Higgs of Plain City, Utah. I've discovered the flight track data from the accident airplane that has not been reported by the news outlets yet, and I've also discovered an ATC audio recording that is a message relayed from the accident airplane to ATC about its engine out failure. It looks like it's an engine out failure followed by aircraft loss of control close to the ground that contributed to this crash. Hi everyone, I'm Mike from the Malibu Mike channel. I'm a 2,000-hour pilot with a flight instructor certificate, and I like to teach people about airplanes and about how to fly them and how to be safe. And so that's what we're going to cover in this video, is how can we be safe when we're piloting aircraft that might have lost significant power from their engine suddenly. So with that, let's get into it. This accident happened on October 10th, approximately 11:25 a.m. It was really hard to find the data because it was not linked to the registration number of the actual airplane. Nonetheless, I found it, and there's some really good information that we can glean from it, and we can learn immediately from this crash and not have to wait 1 or 2 years for the NTSB to come up with a report before we can learn our lessons now. This aircraft is a high-performance aircraft with a fighter-like feel. In other words, you feel like you're flying a fighter jet. And they say that with good reason, because this aircraft cruises at 200 miles per hour, and it is quite a performer. This has a smoke system because this is configured as an aerobatic performer for crowds. So these aircraft are very, very fun to fly. The fun factor is very high. So this is the picture of the VFR chart from where the aircraft departed. It was Sky Park Airport from Bountiful, Utah. Notice that it's extremely close to the Salt Lake City International Airspace. So if you're taking off from this airport, you have to immediately turn to the east and then turn north to avoid the highly protected Class Bravo airspace that otherwise, busting this airspace is a big deal. You can lose your pilot's license for flying into this. So it is nestled very close to the Salt Lake City, Utah airport. The weather conditions at the time of the accident were somewhere between this data point and this data point, because these come out once an hour. The accident happened exactly between these two data points. So we know the winds were somewhere out of the southeast at 12 to 13 miles per hour, or more out of the south at about 22 miles per hour, gusting to 30. I'm converting knots to miles per hour in my head there, in case you didn't know what I was doing. A few clouds at 9,000. The temperature was 22 degrees Celsius, which is about 72 degrees Fahrenheit. When you plug all these into a calculator, this means that if your airspeed indicator inside the airplane says you're doing 78 miles per hour, because of the thinness of the air at this warm temperature at a high altitude airport, you're actually doing 86 miles per hour. So it's off by 8 miles per hour. I know if I had a car that was off by 5, 6, 7 miles per hour, that would bug me. But this doesn't really bother pilots too much because we only really care about the number of molecules that are traveling over the wing that give us lift. So it's okay to only see the indicated airspeed from a pilot's point of view, and just to know under the covers, that you're going a lot faster through the air instead. So this is not too big of a deal for pilots as it would be if you're driving a car and you don't want to go over the speed limit. So given the conditions, it looks like the altitude of the airport felt like it was 6,285 feet, a full 1,000 feet higher than Denver under standard conditions. However, this is a high-performance aircraft. The aircraft here is engineered to have a 200 horsepower engine on it, and when it's fully loaded, it's only 1,800 pounds. So this has a lot of power with not a lot of weight, and therefore it boasts a over 200 mile per hour cruise speed in an ideal cruise configuration. And so even though it was a high altitude airport, that did not really contribute in this accident. So looking at the crash site and looking at the photos from satellite photos and photos around the crash, it looks like it crashed in a fairly flat area. The eyewitness accounts reported that the airplane crashed nose first, nose down. And I would have loved to have been there to ask follow-up questions. What was the angle that the nose was down? Was it 20 degrees, 45 degrees? Was it pointed absolutely straight down? What happened? Because when I hear that it crashed nose first, that made me think that the pilot might have lost control of the aircraft. There are a lot of things that can happen that result in loss of control. It can be a stall spin. It could be a flight control malfunction. It's hard to say exactly what happened here, but from the data, we can infer a bunch of things from this flight. So without further ado, let's take a look at the flight track for this, and we will play the ATC recording shortly. So this flight started normally with a normal speed taxi down the taxiway and then a departure at approximately 11:14 a.m. local time and a half, and it looks like it gained enough airspeed to lift off the runway right about at this point, about 21 seconds later. So notice how the reported pressure altitude is 4450. This is normally reporting 200 feet higher than actual, given the pressure conditions at the airport. So you take every altitude you see in this chart, in this graph, and you subtract 200, and that gives you the real number. That's the take-home point here. So from this point until the end of the runway, it gains approximately 300 feet and goes all the way up to 110 miles per hour. This is a very fun airplane to fly. This point is a point of extreme pleasure. You're just having a ball because there's nothing like feeling the acceleration of a high-performance machine at your fingertips. It just feels like the most fun you've ever had in your life when you're taking off in a high-performance airplane. So the fun is at a maximum here. And as you turn towards the north, the winds out of the south make your ground speed go faster. So naturally, we expect to see some very high numbers here, even though the pilot is only about 1,300 to 1,400 feet above the ground. We see numbers that exceed 200 miles per hour over the ground, which means this airplane was performing at a very nice clip. It continues to travel northbound, and right about the time where it gets over this golf course, over the Davis Park Golf Course, something interesting happens. It appears to be level at this 5850 or 5825 at that altitude, and then it goes from 200 miles per hour to 197, and then here's the big drop-off to 181 to 170 to 139. It loses almost 60 miles per hour in 10 seconds while maintaining altitude or staying within 100 feet of the original altitude. This says a couple of things. The only logical explanation is the pilot pulled back on the power or that the power disappeared. The engine stopped producing significant power between these in these 10 seconds. There's also the fact that when such an extreme event occurs, there's a shock factor. We call it this startle effect. The effect that there's instant denial. I can't believe this is happening. Did I really hear that engine going down? Are my instruments really saying that? I can't believe this. Is this really happening to me? It takes the average pilot 3 to 5, maybe even up to 10 seconds to fully embrace the situation and then respond to it. So this pilot chose to respond by making a 180-degree turn, and by the time that turn was done, he was going 104 miles an hour, and he was approximately 200 to 300 feet lower than he was initially. So now he's headed back in the opposite direction towards the airport that he just took off from. And also notice when he finished the 180-degree turn, what's off to the left? A giant 18-hole golf course. Let's look at this from the satellite view. So the Davis Park Golf Course is a giant blob of 18 holes. It's impossible to miss this thing. It would be an ideal place to set down an aircraft. Does this bring back any memories for any of you? For me, it does. I remember Harrison Ford out in California near Santa Monica Airport landing his high-performance aircraft on a golf course. It was a hard landing. He ended up getting significantly injured on his face, blood all over the place. However, he was in fairly decent condition. He survived it without any significant injuries. So I would have loved to see the pilot make a decision here. If it was me and I lose significant power, I'm looking right around me at this point. Where can I put this airplane down now? Given that you're only 1,400 feet above the ground when this started, and you've been airborne for about 4 or 5 minutes, I don't know how any pilot would expect to make it back to the original point of departure. It's just, especially in a high-performance aircraft that is moving so quickly away from that airport. So I would be looking for landing sites right now. This pilot didn't seem to do that. If it's a partial power loss, okay, if you're losing partial power, now you might believe, oh, the engine, it'll last me another 5 minutes. This will not manifest into a full power loss. And so you believe it will give you enough energy to make it all the way back to the original point of departure. That is not always the case. And that's why partial power, to some, is considered more dangerous than a full power loss. When we are teaching early pilots how to respond to engine failures, we simulate complete engine loss. I look over at my student and I say, you've lost your engine. I pull the power back to idle, and the pilot is not allowed to advance the throttle until they've convinced me that they could make an off-airport landing by selecting a field, lining up with the field, and convincing me that they would make a safe landing in that field if they had to. So this pilot continued to press on. We don't know why. We won't know. I don't know if we'll ever know if it was a full power loss or a partial power loss. If they interview the pilot that heard the distress call, they might get more information. But the information that they relayed was it was an engine out. We don't know how long it took to go from normal power to 0% power, or normal power to 50%, and from 50% to 0. We don't know how long that took. But what I do know is that if a partial power loss happens, I'm going to treat it like a full power loss event. I'm assuming that I have no power left, that anything above that is just a bonus, and that I need to land the airplane on this golf course immediately. That is what I'm doing. This pilot decided that he could press on back towards the airport and make it. So what ends up happening is he gets lower and lower and lower. Now he's at 4,800 feet. He's maintaining roughly the same airspeed, flying towards the airport along the freeway. And he gets to about this point right about here where he realizes he is running out of room. If we look at the satellite view of the pilot as he's traveling along this road, he's seeing these fields here, and he's seeing how he's running out of them, and it's turning into more densely populated areas. At this point, he realizes for sure he's not going to make the airport. And at this point, he's probably making the distress call on the frequency he still had tuned in, that 122.8. And this other pilot that's listening decides to relay this to air traffic control on yet another frequency. Let's go ahead and listen to that relay.
Experimental that just declared on 122.8. He's landing by Legacy, engine out.
He said the experimental that just declared on 122.8. That is shorthand for declared an emergency. So from that recording, we know that this aircraft has declared an emergency, has declared that it has an engine out failure. It declared an engine out. So let's listen to that one more time.
Experimental that just declared on 122.8. He's landing by Legacy, engine out.
That last part, engine out, it's really hard to hear that. Engine out means there's been an engine failure. So at this point, he's getting closer and closer. Probably notices that there's this little ravine here. But at this point, he starts to turn left at a low to the ground and slow. We don't know how much longer the aircraft stayed airborne. And notice this little blue line here. I think this is measuring part of the ravine. I think this larger blue blob represents something that looks like a lake. Is probably not accurate. It's probably from historical information. But anyways, the pilot here is literally painting himself into a corner. He's getting closer to the ground, realizing he's running out of space to put the airplane down and slow down before he impacts a fence or a road or something. And at this point, there's a strong temptation to turn the airplane parallel to the pathway with that fence in front of it. Notice the picture here. There's this large fence. I don't know if it's that visible from the air, but you definitely don't want to. You see the road and the power lines here. You realize that you're probably not going to have a good outcome if you crash into a road perpendicular. So the strong urge here is probably to tighten that left turn. And if you do that improperly, a couple of things can happen. Number one, an accelerated stall can happen, where by banking the wings of the aircraft, you can increase the stall speed significantly. If you maintain altitude and do a 60-degree bank, the stall speed goes up by 41%. That is a huge problem here. you don't have that much room to work with. When it says 86 knots, the indicated airspeed, again, for 86 knots is 78 from this calculator right over here. So when the ground speed says 86, that means that the instrument will say 78, okay? The instrument might be saying higher than 78 because it is going into the wind, right? So if the higher the wind, that means the higher the indicated airspeed that we're seeing. And so we see the net difference between the true airspeed and the headwind. So the strong temptation here is to turn to the left. So it's either an accelerated stall that could cause you to lose control of the aircraft, or it can be the temptation to use inside rudder. Using the inside rudder, you can actually have a skidding stall where you're skidding, where you can stall spin into the ground. Apparently there was a police officer that was traveling on this Legacy Parkway that saw the aircraft crash and described it as a nose down crash, nose first. So what could explain that? If you're in a left turn with a lot of inside rudder and you lose control of the airplane, that's going to look like the airplane is diving down into the left and nose down. So that's a possible explanation, that you're doing a skidding stall or an accelerated stall or a combination of the two, and that's how you lose control of the airplane at the last minute because you're trying to avoid crashing into a fence. The lesson here is to not turn, to make a steep turn close to the ground, but you just accept the fact that you're going to crash into a fence. And it's much better to crash into a fence and not stall than it is to stall the airplane and land in a very unusual attitude, that is the nose pointing straight down, which is almost never survivable when you land very hard on the nose. One more note that I'd like to add is that it's not clear, as a result of the engine failure, if any oil had come over the canopy and blocked the pilot's view from landing. In fact, it's quite common with a complete engine failure that oil happens to get everywhere, and a big part of that is blocking the pilot's view from landing. What are the lessons that we can take to heart and learn from this fatal accident? I think one important lesson is that if we lose partial or full power, we treat all of those as if it's a full power loss event and try to get the airplane on the ground as quickly and as safely as possible. Also, if we get low to the ground and realize it's not going to work, we're too fast, to try not to make any sudden turns or steep turns. It's hard to know if the pilot did that in this case, and we're going to have to interview a lot of eyewitness accounts to see what probably happened in the last few seconds. We're not sure if we lost some data points from the airplane just practically being too low to the ground. It'll be hard to reconstruct the last few seconds of this flight, but for sure we should try to avoid loss of control. As the popular saying goes, fly the airplane all the way into the crash site. You never want to lose control of the airplane, not in the last second. You don't want to stall that airplane. You want to land it into the crash site, drive it into the fence, drive it completely into the crash site as far as you possibly can, but do not give up control of the aircraft. If you use inside rudder to try to steepen a turn, that is a formula for a stall spin disaster. We don't know if that happened in this case, but it looks like a very likely risk, given that this pilot painted himself into a corner, into a spot between a ravine and a freeway, and was likely trying to steepen that turn to try to escape that tight corner, and probably pushed the airplane a little bit too far and lost control of it. So with these lessons in mind, let's learn from these accidents and try not to repeat these mistakes that form a chain of events, and when that chain is complete, it results in a fatal accident. So let's try to break that chain as early as we can. Thank you for paying attention. I appreciate your likes and subscribes. I like chatting with you in the comments section below. I look forward to the conversations we'll be having. So with that, I'm Malibu Mike, signing off. Have a good one.